I'm Indranil, and today we are going to discuss locus of complex numbers. Suppose we have a complex number z, which we are denoting as x plus iy. Okay, we have a complex number z, which we are denoting as x plus iy. Did you know that the real part of z is x and the imaginary part of z is y? Real part of z is x and the imaginary part of z is y. Then graphically, we can denote this point z by the point x comma y. Graphically, we can denote z as a point x comma y. For example, suppose we have some complex number which is 2 plus 3i. So here our x is 2 and y is 3. So we can denote this z by the point 2 comma 3, and then we can plot it on the graph. Our x coordinate is 2, so we'll move 2 units along the x-axis, and our y coordinate is 3, so we'll move 3 units along the y-axis. So thus this point 2 comma 3 will denote z. Now let's see that we are plotting real part of z, that is x, along the x-axis. I repeat it once again, we are plotting the real part of z along the x-axis. So that's why this axis is known as real axis. Means along this axis we'll plot the real part of z. Similarly, we are plotting the imaginary part of z along the y-axis. So we call it imaginary axis. This is okay? So along the horizontal axis, we are plotting the real part of z, and along the vertical axis, we are plotting the imaginary part of z. So now suppose we have some z which is minus 3 plus I. So in this case, how to plot this z? Since the real part is minus 3, along the x-axis, we'll move to minus 3. Imaginary part is 1, so along the y-axis we'll move to 1, and thus this point minus 3 comma 1 will be z. Now suppose we want to find the locus of z for which real part of z is equal to 2. The equation is given that real part of z is equal to 2. I need to draw the locus of z. For that we can consider that since z is equal to x plus iy, so real part of z is nothing but x. So this equation will turns out to be x is equal to 2. And that's why if I draw the line x is equal to 2, that will be a vertical line which is passing through x equal to 2 unit. This will give us the locus of z. This will be the locus of z. So similarly, if it is given, if the equation is given as real part of z is less than or equal to minus 1, that means what we are getting? That x is less than or equal to minus 1. So to draw the graph of it, first to plot x equal to minus 1, which will be again a vertical line passing through x equal to minus 1. And the entire left part of it will satisfy x is less than or equal to minus 1. If I go left of x equal to minus 1, then that was satisfied. X is less than or equal to minus 1. So this should be our locus. This entire plane, the shaded area, will be the locus. Now, similarly, if it is given that imaginary part of z is lying between 3 and minus 1. So what we can say that this is nothing but, since z is x plus iy, this is nothing but y is lying between minus 1 and 3. Okay, that the imaginary part of z is y, and that is lying between minus 1 and 3. So you draw the lines. One line is y equal to 3, which should be a horizontal line, and the other line is y is equal to minus 1, which should be another horizontal. Now, since our y is lying between minus 1 and 3, so we need to now shade the region between these two. Y can lie anywhere between minus 1 and 3. तो -1 और 3 के बीच में y इक्वल टू -1 और y इक्वल टू 3 के बीच में जो एरिया है उसी को हम लोग को शेड करना पड़ेगा. That will give us the locus of this equation. Imaginary part of z is lying between -1 and 3. Now suppose we need to find out the locus for this one. Here, real part of z is x and imaginary part of z is y. So it should be x plus y is equal to 1. So you draw the line x plus y is equal to 1. And that will be your equal locus. Now let's try one little bit difficult problem. Suppose we have some equation given like this. Mod of real part of z plus mod of imaginary part of z is less than or equal to 2. So here what we are getting that mod of x plus mod of y should be less than or equal to 2. Okay. So first thing, when in the first quadrant, x and y both are positive in the first quadrant. So this equation will also to be x plus y is less than or equal to 2. Okay. So we can draw the line x plus y equal to 2. And all the points that is below this line should satisfy x plus y is less than or equal to 2. So this should be the area of the locus in the first quadrant. Now come to the second quadrant. In second quadrant, what will happen? Our x is negative and y is positive. Since x is negative, mod x will become minus x plus y is less than or equal to 2. So draw the line y minus x is equal to 2. And all the points below this will satisfy that mod x plus mod y is less than or equal to 2. Now for the third and fourth quadrant, we can just take the mirror image of this one, since we have mod y here. So here whatever we have drawn, we can just take a mirror image of that due to modular sign in y. And finally, this should be the equal area. It's okay. Now suppose we want to draw the locus for this equation. Mod of z minus z1 is equal to r, where z1 is x1 plus I by 1 of the z1 एक fixed point है, x1 plus I by 1 दिया हुआ है, और r भी एक constant है that belongs to real number, r is a constant. Now if we consider that z is a variable point, x plus iy, then this z minus z1 is nothing but x plus iy minus x1 plus I by 1, which you can further write as x minus x1 plus I into y minus 5. Is this okay? So modulus of z minus z1 will come out to be x minus x1 whole square plus y minus y1 whole square plus square root. That we know already. So this equation is nothing but x minus x1 whole square plus y minus y1 whole square is equal to r square. So we know that this is nothing but a circle with center at x1 y1 and radius is r. So this is a circle with center at x1 comma y1 and radius r. This is okay. For example, let me start. If I want to draw the graph of this, then what you have, we can write this as so which gives you, just compare with the previous form, this gives you x minus 3 whole square plus y plus 2 whole square is equal to 5 square. So in this case, what we are getting that our z1 is now 3 minus 2y. Okay. In this case, what can you say? That z1 is becoming 3 minus 2y and r is equal to 5. So this should be our final result. So it should be a circle with center at 3 comma minus 2 and radius is 5. So it should be a circle like this. Is this okay? We can also discuss this concept in a different way. When you talk about mod of z minus z1, we are talking about the distance between z and z1. So by this equation, what can you understand? That z is a moving point, which is moving in such a way that its distance from z1 is always equal to r. Now, if a moving point is moving in such a way that its distance from a fixed point is always constant, then you know that the locus of that moving point is nothing but a circle. एक पॉइंट ऐसे मूव कर रहा है कि किसी फिक्स पॉइंट से उसका डिस्टेंस हमेशा कांस्टेंट है, तो उस मूविंग पॉइंट का जो लोकस होगा दैट मस्ट बी अ सर्कल. That is another way by which we can explain the same thing without this all calculations. That here this equation is representing that z is a circle which is moving in such a way that the locus of z is a circle. Z is moving in such a way that its distance from z1 is always equal to r. So the locus of z is a circle with center z1 and radius r. Now suppose we want to find out the locus for this one. Now you just see that if I want to write the equation, then it will become this much. Okay, so if we calculate the modulus, we have this one. If you take out the square root signs, if you square root the sides, now you see that we can write this as this. Now use a square minus b square form for the first two, and it gives us a plus b, which is x minus 5, into a minus b, which is minus 1, plus here a plus b, so that is 2y minus 1, and a minus b, that will be 3. This is equal to 0. Which, if we further simplify, we can write as minus 2x plus 5 plus 6y minus 3 is equal to 0. That gives us 6y minus 2x plus 2 is equal to 0. Or in other words, 3y minus x plus 1 is equal to 0. So you observe one thing, that this is finally we are getting a straight line. Okay, we have started with the modulus, but finally we are getting a straight line. Now why this is a straight line? Let us think of it. What is happening in this case? And this straight line is significant. It has some relation with this small notch. What is that? Here we are saying that the distance of z from the point 3 comma minus 1 is same as its distance from the point 2 comma 2. The distance of z is from 3 comma minus 1 is equal to its distance from the point 2 comma 2. Now when, suppose this is the point 2 comma 2 and this is the point 3 comma minus 1. Now when a point is moving in such a way that its distance from both the points is always equal, what should be the locus of that point? Try to recall, we have already did this in our earlier classes. It is nothing but the perpendicular bisector. The locus of z is nothing but the perpendicular bisector of the line joining AD, where A is 2 comma 2 and B is 3 comma minus 1. So the locus of z should be the perpendicular bisector of the line segment, which is forming by joining those two points. So in general, if you have some equation like mod of z minus z1 is equal to mod of z minus z2, then we can consider that the locus of z will be the perpendicular bisector of the line joining z1 and z2. Locus of z will be the perpendicular bisector of the line joining z1 and z2. Okay, today we'll do this in the next class.